Hello and welcome to section 8.4. We're going to be spending a few days on 8.4. We're going to work with the basic stuff today, writing numbers in scientific notation and standard form, so converting between the two forms. And then tomorrow we're going to work with multiplying and dividing numbers in scientific notation. And then the following day we're going to work on some applications with scientific notation. And I'll probably throw in a few word problems throughout as well, so you guys can see how this stuff is actually used. Basically, scientific notation is that comes from working with science. A lot of times in science, there's really small numbers or really big numbers, and so instead of writing those numbers out over and over and over again, we use scientific notation. So here are some numbers that are in scientific notation, what they look like converted. It's a number, C, which is a number between 1 and 10. It could be 1, but it has to be strictly less than 10. And then n is an integer. So this number here is going to be a number such as -3, -2, -1, 0, 1, 2, 3, etc. All right, so here's what you're going to do. Write your numbers in scientific notation. So these are all in sort of standard form, I guess. You're going to place the decimal so that the number is between 1 and 10. So in this case, 4.2. And then you need to include any other number up until you get to the last non-zero number. So you can exclude all of these here, or all of these here. I'll go over a few examples. And then you're going to figure out how many times you have to multiply by 10. And a lot of kids will just count 1, 2, 3, 4, 5, 6, 7, 7th power. That's the traditional way of doing it. One thing that you want to keep in mind is, does your answer actually make sense? So if you multiply 4 times 10 to the 7th, this is going to get much bigger. Because 10 to the 7th is really that number there. If you multiply 4 times that number there, you're going to get what you started with, and the answer is yes. All right, so here I'm going to place the decimal between the 5 and the 7, so it's 5.74, again, between 1 and 10. Now here you're actually dividing to get to there, so you're actually going backwards 5, and so you're going to be doing -5th. And to recall, that -5th is really 1 over 10 to the 5th power. And so you're actually dividing by this number right here. Okay, you're dividing by 100,000. So if you take this 5.74 and you divide it by 100,000, you're going to get a much smaller number. So try to think about what you're actually doing with this process. Here you're not moving the decimal at all, so you're actually just taking 9.6 and you're multiplying it by 1. So 10 to the 0 is equal to 1. You'd never actually see that though. Here you're just moving it back one spot, so 8.9 times 10 to the -1. Again, if you divide 8.9 divided by 10, you're going to get 0.89. 5.09. Let's see, 5.3 million. I'm actually going to write that out for you guys. This is what 5.3 million looks like, 5,300,000. And one more. So this one's interesting. I have to go all the way down to this 9. So 3.00009. You need to include the last non-zero number. That's kind of what I was talking about earlier. And then the number one incorrect answer on this is students will write down 1, 2, 3. They'll do like 10 to the 3rd. Which would be incorrect. You got to count the number of spaces that you move the decimal to. In this case, you got to move all the way down to the 3 and the 0 at the end there. And this is taking numbers in scientific notation and writing them in standard form. So keep in mind what you're actually doing. You're multiplying this number by 1,000,000, so it's going to get much bigger. And the 10 to the 6 does not mean add 6 zeros. A lot of kids will do that wrong. I like to put in my commas here too, just to show how big the number is. I did that wrong. There we go. This one you're taking 1.685, and you are dividing it by a very, very large number, or you're multiplying it by a very small number. So this number is going to get much smaller. 0.000165. And there you go. All right, and then you're going to see problems where you have to order the numbers from least to greatest. You have two options: convert them all to standard form, convert them all to scientific notation. It doesn't really matter either way. Commas will be your friend here. Okay, so I have 780 million. Okay, that's number one. I have 103 million, that's number two, and I have 80 million, that's number three. So, here are your two options. I like standard form, I guess, better, but you can do as you wish. And then here's a word problem. It says we got some satellites here. Spacecrafts Voyager 1 and Voyager 2 were launched in 1977 to gather data about our solar system. None of this information is relevant for us solving our question. As of March 12, Voyager 1 had traveled total distance of this many miles. Okay, again, the date really doesn't matter. And Voyager 2 had traveled a total distance of this many miles. Again, all that stuff is irrelevant except for just the distance. Which spacecraft traveled the greater distance at that time? So all this question says is which one of these two numbers is bigger? So we had all those words for a very simple question. I'm going to convert this into standard form so I can compare the two numbers. 9065. Okay, so that would be this number in standard form, and we got 9,065,000,000. So Voyager number 1 was our winner. They have traveled about 600 million more miles. And that is converting between scientific notation and standard form. Thanks guys for tuning in, and I'll see you for another day of 8.4.